You are welcome to learnwithbonitas.com. Today we'll be looking at motion. Remember that a body is said to be in motion if it is not in its state of rest. As I move, I change this position with time. So when a body is not in its present state of rest, the body is said to be in motion. Remember the parameters we use to measure motions or to calculate the motion of a body. But it's very important that to understand that motion, there are different types of motion. A body can move on a straight path, what we call the translational motion. The body can move in a circular path, that is a circular motion. A circular motion. We also have rotatory motion. The motion of a wheel of a vehicle is rotatory. It's different from circular motion. This is circular. Rotatory motion is the motion of a wheel. We have translational motion, motion on a straight path, and we have oscillatory motion, fro and toe motion. We also have vibrational motion. All these are different types of motion. So we're going to start with translational motion, or what we call rectilinear motion. Rectilinear motion, motion on a straight path. If it is like this, the motion is a horizontal motion. If it moves like this, the motion is said to be a vertical motion, either up or downward. Horizontal motion is not the same with vertical motion. In horizontal motion, it is not affected by the gravitational force, but vertical motion is affected by the gravitational force, or what we call the force of gravity, the force on the surface of the earth that tends to pull down every object that is moving upward. That force is called force of gravity. Only affects this motion, vertical motion. It does not affect horizontal motion. So in rectilinear motion, we have to look at the equations of rectilinear motions. Before we do that, what are the parameters used in measuring motion? The first is the distance and displacement. Remember, I've told you the difference between distance and displacement. Displacement is still a distance, but it's a distance traveled in a specified direction, as I've said earlier. It's a vector quantity, it's a scalar quantity. Speed or velocity. Velocity is a distance, a displacement covered by a body in a given time. That's rate of change of displacement. So velocity is a vector, speed is a scalar. Do not forget. We have the acceleration, change of velocity with time. Then we have the time. These four important quantities are necessary in understanding motion. So if the speed v or velocity is change in distance or displacement over time, change in displacement over time. Remember, acceleration is change in velocity over time. That is rate of change of velocity. Here, distance is measured in meter, time is measured in seconds. So the unit of speed or velocity is meter per seconds, or you can write it like this, meter per seconds. The unit of acceleration is velocity is already meter per seconds over seconds, which is meter per, which is over seconds divided by seconds, which is equal to meter per seconds times by 1 over seconds, which is meter over second square. That is meter per second square. That becomes the unit of measuring acceleration. So in this class, we'll be looking at equations of rectilinear motion, equations of rectilinear motions, and calculations in rectilinear motions. For example, equations of linear motion. First one, we say that the acceleration is change in velocity over time. Is it not? That is change in velocity over. What is change in velocity? Change in velocity means the first velocity and second velocity is not the same. It changes with time. That is final velocity minus initial velocity, right? All over time. The final velocity is represented with, do not forget, final velocity is represented with V. This one is average velocity. Why this one is change in velocity, sorry. So final velocity minus U, initial velocity all over time. So AT is equal to V minus U when we cross multiply. So V is equal to, if this come over here, becomes U plus AT, equation 1 of motion. Now, so the first equation of motion is that V is equal to U plus AT. Now, if I say that velocity is change of displacement over time, or speed is distance over time, this displacement S or distance is equal to velocity times time, right? The velocity here is not the initial velocity, is not the final velocity, is the average of the two velocities. So I can say that this velocity is average velocity times time. So S, what is the average velocity? Both the initial and the final is this velocity divided by 2. Since velocity often have initial and the final velocity, because in a motion, if motion of body changes with time, that is acceleration, there will also be change in velocity because of the acceleration. So U plus V over 2 is the average velocity times time, but V is equal to U plus AT, right? This V is the final velocity now. So S is equal to initial velocity plus, what is V? Final velocity, U plus AT all over 2 times T, is it not? So S is equal to U plus U is 2U plus AT times T all over 2. So S is equal to T times 2U, 2UT plus AT times T, AT square all over 2. What does this mean? It means that S is equal to 2UT, 2 is owned by both of them, plus AT square all over 2. This 2 is owned by both of them, 2 is the LCM. So this can cancel this. S is equal to UT plus AT square over 2, equation 2 of equation of motion. So we'll put it down. The second one is that S is equal to UT plus AT square over 2, equation 2. The last one is, if V is equal to U plus AT, we square the both sides of the motion to get our last equation of motion. We're going to have V square equal to U plus, when we square the both sides,